Assalamu alaikum and good evening everyone. So now we are going to see the problem solving y double dash plus 2y dash minus 3y equal to sin t, which is a second order differential equation. We need to get the solution applying the method of Laplace transform. So it has got two parts basically. We are going to start the procedure to start with part 1. So part 1, consider the given differential equation y double dash plus 2y dash minus 3y equal to sin t. We understand the problem is a second order differential equation because the derivative shows y double dash is a second derivative. It is the highest order. So this is defined to be a second order equation. Because we are going to use the Laplace transform, to start with the procedure, step 1, applying Laplace on both the side of the given differential equation. So we'll have L of y double dash plus 2y dash minus 3y equal to L of sin t. Now using the linear property of Laplace transform, we understand Laplace separates plus and minus. So from this bracket term, Laplace is going to separate every term which is in the form of plus and minus. So you open the bracket literally, you get L of y double dash plus L of 2y dash minus L of 3y equal to, right hand side L of sin t has got the standard formula, that is 1 by s square plus 1. Because we know L of sin at, the Laplace formula is L of sin at, the Laplace formula is L of sin at, the Laplace formula is a by s square plus a square. So on comparing L of sin t with L of sin at, we find in place of a, the coefficient of t is called a value. So coefficient of t is 1. So substituting in this formula 1 by s square plus 1 square. That is what we have given. L of sin t is 1 by s square plus 1. Now coming back to the next step, we find L of y double dash, L of 2y dash. See, we see the Laplace brings the constant outside when it is in the product of a function. So this 2 will come out, we get L of y double dash. This 3 will come out, so this will give you 3 L of y equal to 1 by s square plus 1. Now after which L of y double dash and L of y dash is the formula using Laplace formula is available using the derivative. Using this property only we are going to solve the problem. So L of y double dash formula is s square L of y minus s y of 0 minus y dash of 0. L of y dash formula is s L of y minus y of 0. So this is going to be substituted in the place of L of y double dash and L of y dash. So when we substitute L of y double dash in this place, we get s square Ly minus sy 0 y dash 0 plus 2 of Ly dash substitution is giving us Sly minus y of 0 minus 3 L of y equal to 1 by s square. So moving ahead to the next step. Now what is happening? S square L of y minus sy of 0. There will be always, there is a constant called y of 0 and y dash of 0 whose values will be always accumulated in the given question. So we will go back to the question. There is something called y is equal to y dash is equal to 0 and t is equal to 0. What does it mean by this? When the function are going to be, given function are expressed in terms of y, where y is a dependent variable and t is the independent variable, the general function is called as y of t and y dash of t. So here the value given as y is equal to 0, y dash is equal to 0, which means y of t equal to 0 and y dash of t equal to 0. In turn, t value is given as 0. So this is rewritten as y of 0 equal to 0 and y dash of 0 equal to 0. By this way, we are able to get y0 value and y dash 0 value, and this is going to be substituted in the place y0 as 0 and y dash 0 as 0 in both the bracket term. So therefore, on solving, we will arrive s square Ly, s into 0 will become 0, this 0 also will vanish. 2s Ly, this 0 will vanish. minus 3 Ly equal to 1 by s square plus 1. So we get now the next step, as I said, s square L of y plus 2s L of y minus 3 L of y equal to 1 by s square plus 1. So we come to know here also L of y, here also L of y, here also L of y is common. So let us take L of y common outside. So what will be inside? When L of y is taken, s square will come inside. Here 2s will come inside. Here 3 will come inside. So taking L of y common, these are the three remaining terms inside the bracket. Right hand side will have 1 by s square plus 1. So we have to, from here we'll find, have this L of y on one side. This product term comes to the other side of the equation in the form of denominator. It will come to the denominator on the other side. So hence L of y equal to 1 by, already s square plus 1 is present. This term is coming to this side. S square plus 2s plus 3. Actually the question is to solve y double dash plus 2y dash minus 3y equal to sin t. The function for this given equation is y. So solving should give the value of y. Because of this reason, from L of y, I should find what is y. So bringing this L on the other side will become L inverse. So y is equal to L inverse of 1 by s square plus 1 into s square plus 2s plus 3 is a resulting expression. And this expression is called as equation 1. So hence, to proceed further, this completes part 1. To proceed further, to get the value of y, we understand we have to find the inverse Laplace transform of this given expression. So therefore, we move on to the part 2 for finding the inverse Laplace transform. So we call this y expression as equation 1. We are going to find the answer for L inverse in the part 2, and that answer will be substituted here in equation 1 to complete the solution. So to start with part 2. What is part 2? Evaluating this inverse Laplace transform. So consider the entire L inverse function over here. L inverse of 1 by s square plus 1, s square plus 2s plus 3. So our observation by the understanding of inverse Laplace transform is, whenever the denominator function is a product of expression, the inverse have to be done by solving the expression inside this bracket, applying the partial fraction method. So therefore, let me proceed considering this L inverse of 1 by s square plus 1 into s square plus 2s plus 3. So we come to know this s square plus 2s plus 3 is a quadratic expression. S square plus 1 is also quadratic expression. So we will, before going to the method of partial fraction, we need to check whether this quadratic expression can be factorized. S square plus 1 cannot be factorized, whereas s square plus 2s plus 3 can be factorized. How? S square plus 2s plus 3. So what is the method of factorization? You consider the constant that lies in the extreme. Find the factors of this constant. The constant is 3. The factors of 3, the tables of 3 are 3 ones are 3. When you add or subtract 3 and 1, you should get the middle term. So 3 minus 1 is 2. So this 2s is splitted as 3s minus 1s. So that from the first two term, s square plus 3s, we can take s common. From 1s minus 3, no common. So you can take as one table outside. So that inside the bracket, you should have the same expression. So you get s plus 3, and the remaining s minus 1 becomes the other factor. That is s plus 3 into s minus 1 are the factors of the expression s square plus 2s plus 3. So this is giving us an understanding. L inverse of 1 by s square plus 1 into s square plus 2s plus 3 can be rewritten as L inverse of 1 by s square plus 1 cannot be factorized. So we write it as such. S square plus 2s plus 3 will be has been factorized, and the factors are s plus 3 into s minus 1. So now we proceed. 1 by s square plus 1 into s plus 3 into s minus 1 is rearranged as 1 by s minus 1 into s plus 3 into s square plus 1. What is the reason? See, this is s power 1, this is s power 1, but this is s power 2. So whenever we go mathematically, we always arrange the functions in order of ascending order. First s power 1 term, then s power 2 term. So this is rearranged only for this reason. You keep s power 2 term towards the end. So we have 1 by s minus 1 into s plus 3 into s square plus 1. So that we apply the method of partial fraction. This is separate as. So if s is power 1, you have to define one constant. If s is power 2, we have to define two constant. So every factor will take one constant in the separation of partial fraction. So s minus 1 is taken as a by s minus 1. S plus 3 is taken as b by s plus 3. And s square plus 1, because it has got power 2, it is expressed in the form of two constant, cs plus d divided by s square plus 1. So this separation is done by knowing the by the method of partial fraction. So and this resulting expression, what we have separated using the partial fraction, should be called as the next equation number according to our problem, equation 2. Now we have to get the value of a, b, c, d, which are merely constant, in the following way. So we find the right hand side all fractional term. So whenever you have fractional, you combine all the fractional term taking LCM. So how to take left hand side, we will not disturb. Left hand side we will not disturb, because left hand side is a expression that we have got in our question. Right hand side we have to simplify. So how are we going to simplify? S minus 1, s plus 3, s square plus 1 is taken for LCM. All three different term. So this is going to be the product of the different term as LCM. S minus 1 into s plus 3 into s square plus 1. Now numerator, you compare every fractional term with the denominator LCM. Whichever the denominator is missing with the LCM, that is multiplied with the constant. So first one, a by s minus 1 compared with the LCM, s minus 1, s plus 3, s square plus 1. S minus 1 is present in the LCM, but s plus 3, s square plus 1 is missing for constant a. So you multiply a into s plus 3 into s square plus 1. Likewise, b denominator compared with LCM, s plus 3 is present. Who is missing? S minus 1, s square plus 1. The missing is multiplied with the numerator of b. When you come to the third part, s square plus 1 is there in the LCM. S minus 1, s plus 3 is missing, is multiplied with the numerator of cs plus d. This is the way we have to take LCM and to add the fractional term. So this is going to give us in the following next step as 1 is equal. Now once the LCM is taken, both the side you will see denominator is same. So it will get cancelled. Numerator will be equated. Denominator numerator is 1 and right hand side numerator is a big expression. This big expression is going to be called as equation 3, the following number. Now I have to get the value for a, b, c and d. This is our aim. How to get the values for all the constant? Randomly we give suitable values for s. When we give values for s, you will take care, you can give any value for s, but the hint is whichever the value of s is possible, it will make one of the constant a known value, other constant become 0. That is to start with. So if I going to put s is equal to minus 3, reasonably a becomes 0 because minus 3 plus 3 is 0, 0 into anything is 0. And here also when I put minus 3, cs plus d will become 0 because 0 into anything will be 0. I'll be able to get the b value. So I put s is equal to minus 3 as a option of s value in equation 3. Substituting will give, as I said, a becomes 0, cs plus d becomes 0. So we get b value as minus 1 by 40. So now we go for the next selection of s value as 1. When we select s is equal to 1, the same thing is going to happen as I said in this equation. Putting s is equal to 1, make b as 0 and b as 0 because 1 minus 1, 0 into b is 0. Here also 1 minus 1, cs plus d equal to 0. We will be able to get the a value. So you put s is equal to 1 and subsequently we find substituting b becomes 0, cs plus d becomes 0, a alone there will be some value. Substituting you will get a is equal to 1 by 8. Now you go for, there are no other possible values to make the constant 0. So whenever there are no other possible values, we can always give an easy value selecting s is equal to 0. Put s is equal to 0 in that equation, the big expression, so that we have a into 0 plus 3, 0 plus 1. B into 0 minus 1, 0 plus 1. C into 0 plus D, 0 minus 1, 0 plus 3. Simply put S is equal to 0 because it will be easy for us to calculate and get the remaining constant. We will find 1 is equal to 3a minus b plus d into minus 3, where 1 is equal to 3a minus b minus 3d. So here you have so many constant, but where already a value we found previously and b value also we found. Substituting a and b over here and taking proper LCM and simplifying, we find d is equal to 1 by 5. So far a value is ready, b value is ready, and d value is ready. The other values left out is to find c value. Now we go for c value. Put s is equal to next random value you can select, because already we have substituted s is equal to 1. We have substituted s is equal to minus 3. We have substituted s is equal to 0. Now it is your option. You can give s is equal to minus 1, s is equal to 2, s is equal to 5 as you wish. But we always go for simple number. It is easy for calculation. Put s is equal to minus 1 in the same equation 3, and we find substituting 1 is equal to 4a minus 4b plus 4c minus 4d. We already got a value, b value, d in the place of a, in the place of b, in the place of d. Substitute the found values and taking proper LCM, you see we are left out with 4c. So just here what happens, 4 2s are 8 cancels, 4 10s are 40 gets cancelled. So you will be left out with 1 by 2 plus 1 by 10 plus 4 by 5 plus 4c. 1 by 2, 1 by 10, 4 by 5 are numbers. So we can take LCM, and 4c is one alphabet, so you keep it separately. Taking LCM will give us 14 by 10 plus 4c. I want to get the value for c. So have 4c on one side, the remaining 14 by 10 on the other side. 1 minus 14 by 10, taking LCM will give you minus 4 by 10. So 4c is equal to minus 4 by 10. I will see the 4 on the other side. We find c is equal to minus 10. This is to calculate a b value. So now we have to understanding found a, b, c, 4, all are ready. Now what we have to do? Substitute all these 4 values going into our equation. Substituting all the 4 values in equation 2. What is equation 2? Going back to our previous page where we have taken as partial fraction. This expression is only be named as equation 2, where you got a, b, c, d constant. All the values we got it now. We got a is equal to 1 by 8, b is equal to minus 1 by 40, c is equal to minus 1 by 10, d is equal to minus 1 by 5. So in the respective places we have substituted all the value. This complete my equation 2. Now let us start solving this part. Now after part 2 is like this. First we will separate using the partial fraction. We will get all the values, and finally we apply L inverse on both sides. Why do we apply L inverse of both sides? Why do we apply L inverse of both sides? Because in my part 2, I have to find L inverse expression. So to know the L inverse expression, first I simplified what is there inside the L inverse using the method of partial fraction. So using the method of partial fraction, when I simplified, I get this expression. Now I apply L inverse on both sides. So this is the procedure I go ahead. So applying L inverse on both the side. Left hand side becomes my part 2 expression. Right hand side I have to simplify. So again L inverse separates plus and minus. So L inverse of 1 by 8 by s minus 1. L inverse of minus 1 by 40 s plus 3. L inverse of, see, we know that minus 1 by 10 s into minus 1 by 5. can be treated as with single denominator s square plus 1 and split the numerator. So minus 1 by 10 s by s square plus 1 minus 1 by 5 by s square plus 1. I will repeat, whenever you see an expression, you can treat the denominator as a single expression and split the numerator. So it has got two parts. So here you have only one part 1 by 8 solely. Here you have only one part 1 by 40 solely. But here you have got two parts. One is s by 10, the other one is 1 by 5. So for the simplification purpose, treat the denominator s square plus 1 as a single expression and split the numerator s by 10 by s square plus 1, 1 by 5 by s square plus 1. This is what we have done here. L inverse, because L inverse separate plus and minus, L inverse removes the constant outside. This will have the next step as 1 by 8 L inverse of 1 by s minus 1 minus 1 by 40 L inverse of 1 by s plus 3 minus 1 by 10 is a constant outside. So L inverse of s by s square plus 1 plus minus 1 by 5 is a constant, bring it outside. L inverse of 1 by s square plus 1. That's all. No more simplification is possible. Now we have come down to the formula. 1 by 8 L inverse of 1 by s minus 1 is e power t. Minus 1 by 40 L inverse of 1 by s plus 3 is e power minus 3t. Then L inverse of s by s square plus 1 is cos t. And L inverse of 1 by s square plus 1 is sin t. So formula is done. This resulting expression by the order called as equation 4. So now we have come down to the final part of our solution. So we see y is equal to L inverse 1 by s square plus 1 into s square plus 2s plus 3 is called as equation 1. Here what is inside this L inverse we found as equation 4. We are going to substitute this 4 in equation 1. That is what we say, substituting 4 in equation 1 is going to complete our solution, and this is our answer.